This still active albeit currently quiet volcanic field contains almost everything a volcanologist could ask for. An originally 16,000-foot tall stratovolcano which once had substantial glacial coverage, lava domes, cinder cones, Mar explosion craters, lava tubes, and even some obsidian-rich lava flows. In total, these more than 600 distinct vents have been emplaced across the last 6 million years, being spread across an area of just under 6,000 square kilometers. With the exception of 5 vents which erupted multiple times, every other vent is monogenetic, meaning it erupted once and then never erupted again, with Sunset Crater being one such example of a monogenetic vent. These vents generally get progressively older the further west you go, hotspot origin, and younger the further east you go. While we aren't 100% sure why this volcanic field exists, this trend of younger volcanism moving opposite the direction of the North American plate suggests an origin of an underlying mantle hotspot which is likely 100 to 200 degrees Celsius hotter than the surrounding mantle. This causes more buoyant molten rock to rise and intrude into the crust, forming a cluster of volcanic vents. Most initial eruptions erupted low-viscosity basalt lava, which traveled fairly sizable distances and formed cinder cones. Mar explosion craters would form if substantial groundwater existed overlying a rising magmatic intrusion. Polygenetic centers, however, if an unusually large batch of magma remained in the crust for an extended period of time, it could experience fractional crystallization, allowing for more viscous lava varieties to erupt multiple times and form a polygenetic center. This formed the andesite to dacite lava dome complex volcanoes of Bill Williams Mountain, Sitgreaves Mountain, Kendrick Peak, and O'Leary Peak, alongside the generating of a towering stratovolcano which for more than 100,000 years was likely the tallest point in what is today the lower 16,000 ft volcano U.S. states. San Francisco Peak represented a towering stratovolcano which at one time was quite similar in appearance to California's modern Mount Shasta. It formed through hundreds of explosive eruptions which emplaced overlapping layers of andesite lava and ash, rising eventually to an elevation of 16,000 feet. However, probably due to a cryptodome forming on its eastern flank, a lateral blast ensued, causing large sections of the volcano to slide away like what happened at Mount St. Helens in 1980. This left behind a large east-northeast horseshoe-shaped scar, with the tallest remnant peak today being Humphreys Peak. Eruptions in recent eruptions have solely occurred in the eastern one-third of the field, forming Miriam Crater 20,000 years ago whose lava flows temporarily dammed the Little Colorado River, SP Crater with its highly scenic cinder cone and basaltic andesite lava flow in 3750 BCE, and Sunset Crater in the year 1085. Future eruptions. While this volcanic field will certainly erupt again, its recent rate of eruptions seems to be on the order of around once every 4,700 years on average. Future eruptions could be mildly explosive or highly explosive, although the most likely future eruption type will form a basaltic or basaltic andesite cinder cone with an associated lava flow. Since ash emissions during any future eruption could disrupt regional air traffic, and the major city of Flagstaff is fairly close by, the U.S. Geological Survey designated the San Francisco Hazard Rating volcanic field as a moderate threat volcano. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.